Now the math number 5, this is basically a little bit of critical math, because now you have to consider so many things. You can not only using these formulas, but you also have to connect that relationship between the formulas, and you have to also use different kinds of the unit exchange unit extension, because sometimes there will be not the bits will be given directly. There will be, you need to do some kind of conversion between these bits and characters and frames, and different kinds of the things. And based on that, we can say that our math number 5 is a little bit of critical math. So let us now take one step at a time, and let's see how we can solve this type of the math. The math description says they consider that you are a maintenance engineer of a networking company at Rupgant. Your company multiplexes 5 channels where each of them sends 50 pages per second. Okay, now they're not sending any kind of bits, now they're sending pages, where each of the pages contains 200 characters. Okay, we're sending 50 pages, and in case of every page, and in case of the each of the pages, now this is contained by 200 characters. And if 5 characters at a time are to be multiplexed using the concept of the TDM with 1 synchronization bits added, then answer the following questions. Okay, so many informations and so many types of the conversion we can already see. The first one is that now they are not sending any kind of bits. In the previous match, we said that they have been using different kinds of the bits, kilobits, kiloframes, or bits, now different types of the things. Now they're not sending directly the frames or the bits. Now they are sending that you are sending pages, and each of the pages now contain the characters. And so even if they don't have any kind of direct hint or direct equation or direct kind of the data, we have to find using the characters and the page number. Now we know that for each of the characters we have the 8 bits, and then we can find how many total number of the, what is my input frame rate. If the 5 channels are sending 50 pages per second, and each of the pages now contain 200 characters a second. Now the question number 1, that is the, I think the question number 1 is going to ask you the same thing. Yeah, what is your input data rate for each of the connections? Okay, the thing is that you have 5 channels. Each of the channels, they are sending 50 pages. Okay, and each of the page now contains 200 characters. Okay, this is the same, these things are the same for the each of the 5 channels. So question number 1, to answer the question number 1, we know that each of the characters have 8 bits. So the input data rate for each of the channels, so input data rate would be a simple multiplication, a simple conversion between the pages to characters and then characters to the bits. We have 50 pages. Each of the pages carry 200 characters, and we know that each character is 8 bits. So basically, a 50 into 200 into the 8, that is going to give us the rightful answer. So so how many things will be there? So there will be basically, so 200 into 40, so that will be 8,000. So 800, then 00 BP. Okay, so basically that is going to be our, how many bits? 80 kbps. So your input data rate, now your input data rate is now 80 kbps. So each of the line is now sending an 80 kbps of information. 80 kbps. Then let us find the second one. The second one is sending us what is your input bit duration. Okay, this is easier one. We know that for any kind of data rate or bits, the input data rate is the inverse of the input duration or the duration, and or the vice versa. So now we know the input rate. So the input bit duration. So the input bit duration will be the simply the reverse of this. So 1 divided by 80 into 10 to the power 3. So that is going to be our, so if we do these things, so 1 divided by the 80. So basically 1.25 into 10 to the power minus 5 second. This is going to be our second. Okay. Now for the question number 3, what is my frame rate? Okay. Now this is interesting. Now we know that we have two formulas. So the frame rate, the frame means the output frame rate. The output frame rate is going to be one of these formulas. Either it has to be the multiplexing unit, using the multiplexing unit, or it has to be, okay, either it has to be the multiplexing unit, or it has to be using the frame duration. Now we don't know the frame duration, so it must have to be the multiplexing unit. So the output frame rate is basically the input bit rate or input data rate, whatever you might prefer to call it, divided by the multiplexing unit. Okay, now we have to, now we know the input bit rate is 800 kbps. Okay, so 800 into 10 to the power 3 bps. 80 into 10 to the power 3. This is 80 kbps. Sorry, I'm just saying 8. This is not the 8, this is 80. Now we have to find out what is my multiplexing unit. Now we cannot assume that there will be 1 bit multiplexing unit by default, because there is some kind of information is given here. It says that if 5 characters at a time are to be multiplexed using the concept of the Tdm. So now they're saying if 5 characters at a time to the multiplexing unit. So your multiplexing unit will be either 5 characters, or now as you have, this is your DPS, right? So you have turned these things, everything into the bits. So what you could do, now you have to turn these inputs in the characters in also. So as you have done the upper portion, okay, the 810 to the power 3, and so your lower portion of the denominator will be also 500, 5 characters. So that means the 5 into 8. So basically that will be giving you the answer. Because in the previous, because you have to keep everything using the same unit. So 880,000. So that's going to be our 80 into 10 to the power 3. So 10 to the power 3 divided by the 5 into 8. So that is going to be give us the 2000 answer. So 2000 FPS, or we can say the 2 kilo FPS. It is our output frame rate. Okay, so I hope that you can understand these things, because now they are saying they have been very much specific about the multiplexing unit. They're saying the 5 characters at a time, so you have to use the 5 characters at a time. Now question number 4 is also easy. They're sending this, what is my output frame duration? So your output frame duration is basically the reverse of this. So 1 divided by 2000, right? So that is going to give us the so 1 divided by 2000. So basically that is going to give us the 5 into 10 to the power 5 into 10 to the power 4 second. Sorry, this is going to be 5. 5. Or you can also say this is going to 500. So you can convert them in 500 millisecond, or sorry, a microsecond. And the fifth one, what is my output data? Okay, now the things are also interesting. My output data rate could be one of these formulas, no synchronization bit and the synchronization bit. We cannot use the first one. We cannot use the first one of the synchronization bits, because now they have and one synchronization bits added. Okay, so we have to also go for the second one. We have to go for the second one where we know the frame rate into the frame size. Nice one. So now do you know the frame rate? We know the frame rate. Okay, we know the frame rate. The frame rate is going to be the 200 fps. So this is our frame rate, and now we have to find the frame size. Okay, now we have to find the frame size. Okay. The frame size is an interesting one. It's a challenging one. Um, so we know in that cases, so we know that how many slots will be there. Now we are going to find the frame size. Okay, so how many slots would be there? There will be 5 slots because we are having 5 channels. So 1, 2, 3, 4, and then 5. Okay, that will be my 5 slots in total. 1, 2, 3, 4, and 5. Because each we know that in case of the Tdm, the synchronous Tdm, we will have the number of the slots equal to the number of the channels, right? Number of the slots equal to the number of the channels. Now, how many bits or how many things will be packaged in each slot? Basically, in each of the package, we know that one multiplexing unit, or if we look at this formula, we know how many one multiplexing unit is equal to number of the bits in a slot, right? So one multiplexing unit is equal to number of bits in a slot, or number of bits taken at one input interval. Now, from this map, from this information we have been given there, we know that we are multiplexing 5 characters at a second. So 5 characters. So there will be 5 characters, so not a second, one multiplexing unit, one interval unit. So 5 characters, 5 characters, 5 characters, 5 characters. Okay, is that all? Is that all we have been done inside a frame? Not yet, because we know there will be one synchronization. So we'll be adding one synchronization, and that's going to be a bit. You have to very much be careful over here. People make a common mistake. So what is my frame size? What is my frame size? People make a mistake. People say that, okay, there are 5 or 6. There will be 6 what? 6 bits. Okay, some people say this is a 6 bit. Remember, this is a wrong thing. You cannot say there are 6 bits, because in the previous 5 cases, so in the previous 5 slots, that was a useful slot. In each of the useful data slots, you have 5 characters, not the bits. So you have to go by the formula. You have to bit. So you have to transform these characters into the bits, and then you have to do the calculation. Now the bit value, the frame size is going to be the how many bits you have. In each of the bits, you have 5 characters. Okay, you have 5 characters, and you have 5 characters over the 5 slots, 5 characters into 5 slots, right? Because those are going to be your how many data portions you have, and then you have an extra 1 bit added for the synchronization part. Now let us do this math. For the 5 characters, you know that 5 into 8, this is your bit conversion, and then you have how many slots you have in those 5 things, how many bits you have in those 5 slots, plus one of the bits. Okay, plus one of the bits you have. So basically, this is going to be 5 into 8. So 5 into 8, 40, 40 into 2, that is 200 plus 1. So basically those are giving you that 201 bits. So your frame size, in this case, you have a total of 201 bits. Okay. So what is going to be my bit rate? So bit rate is going to be using this formula. So my bit rate is going to be using the frame rate. So the frame rate into the frame size. So your frame rate in this case is 2000 into your frame size is 201. So if you multiply them together, you will have and 400 or yeah 2000 402 bps. If you want to convert them, that's going to be 4 point. If you can convert them, that's going to be your 402 kbps, or if you can convert them more, okay, so 402 kbps, 402 kbps, or you can convert them into the mbps also. So your bit rate is now 402 kbps. Okay, so what is your, and for the sixth question, it's just a plain simple inversion. You have you've done the first math number 5, and for math number 6, question number 6, what is the output bit duration? Basically the inverse of the output. So output bit duration is basically the inverse of them. So 1 divided by 402 kbps. So basically that's going to give us 1 divided by 402. So that is going to give us the formula of 402, then 000. So 2.48 into 10 to the power minus 6 second, or 2.48 microsecond. Basically, that's the answer. Now, if they ask you as an extra part, now if they ask you for the question number 7, for the question number 7, let's say for the question number 7, they're going to ask you, this is question number 7, so I will have one less. What is your efficiency? So what is it, efficiency? Efficiency is basically the ratio of the useful data bits divided by the total bits. Okay, so how many bits you have passed, how many bits you should pass. So we know that for the case of, we could have 200 bits, useful bits, because this portion, because we know from that portion 200 bits were all 200 bits. The 200 bits was my original characters that was multiplexed, and one of the bits were just been added. 201 to the one bit. The one bit is for the synchronization. So if you do this thing, that will give you the efficiency part. So 200, because the 200 divided by 201, so that is give you the almost 99% of the efficiency. You are losing 1% efficiency because just for this one bit of the synchronization. Okay, so that will be the mathematical solution for all 6 types of the maths. Okay, I hope that has been informative to you, and I would like to thank you for viewing this.